Now that the engine's running, we've got it adjusted to 1,000. After engine start section in your book. Oil pressure, green. So we look at the oil pressure gauge. There's a green section, and the needle should be pointing at it. This ensures there's enough oil pressure to keep the engine running. In a car, it's a simple oil light, or even a simpler check engine light. In a plane, well, it's more crucial. You can't just stop and open the hood. So in the walk-around, we would physically check the oil level with a dipstick. This pressure check is to ensure that it's delivering enough pressure of the oil to lubricate the engine. I mean, it's very important. So that's what we're checking for. Quick check, make sure it's in the green. The next checklist item, avionics power switch on. Remember, we had it made sure it was off while we turned the engine on. So it's usually a white switch. You see it on your panel. We can now safely power on the electronics. Let's also set some other switches now that we have power. The first one is the flashing beacon. Make sure it's on. This is a red light at the very top of your vertical fin, the rudder stabilizer. From an external view, you would see it flashing red on and off. Some planes also have one on their belly, visible in flight from other planes below. Next checklist item, nav lights on. Just like in boats, a green one on the wingtip on the right side, the starboard side, and a red light on the wingtip on the left side, the port side. These lights aid others to determine which way you're traveling and help with visibility, in day or night. So I leave them on for visibility in these crowded airports that we train in because, well, we want to be seen. Many checklists say to use them only at night, but with these newer LED lights, they never burn out and they sip very little power. We just leave them on. I want to be seen, right? If you switch to the external view, the S key, and use your hat switch to look around, you'll see the beacon and the nav lights are already running. All right, so flaps. Now here we go. We haven't learned the theory about them yet, but the flaps, we extended them down. Now we're going to retract them up so that they're streamlined with the wing. We look at the parts of the airplane to see what these look like. They're on the left and the right wing closest to the cabin, and they hang down dramatically. Or they're in the up position and they're streamlined with the wing. When they're up, they are not noticeable. But when they're down, you can tell. We want them full up for a normal takeoff. So we'll use flaps when landing, slow flight, and performance takeoffs such as short field or soft field takeoffs in our intermediate course. Next checklist item, ATIS copy and check the altimeter. All right, so we tune our communications radio, or what we call our comm radio, to hear a constant announcement of the airport conditions. This isn't a weather report, it's an airport conditions report. Many things are said here, and we will listen and write them down on our notepad. Usually it's on your knee or it's on your thigh. You have a notepad you can write on at any time. The two main things we're listening for are the active runway and the altimeter barometric pressure setting. Here in the simulator, in this easy setting, the barometric pressure is always the same at 29.95. But I want us to get in the habit of touching the altimeter set knob every time we hear it, all right? So let's set the radio frequency to the ATIS. Now the ATIS stands for Automatic Terminal Information System. And the frequency is noted on your checklist card for this airport. Look at the airport diagram. You'll see the ATIS is listed there, 133.6. So we will also be listening to this report when we are returning to the airport to get up-to-date information, probably 10 or 15 miles out. We'll listen to the ATIS before we call the tower, and we'll let the tower know we have the ATIS information. Let me demonstrate how to set it.
Toronto Island Airport information, Foxtrot 1436 Zuma, wind calm. Visibility greater than 20 miles. Sky conditions, clouds at 5,500. Temperature 2.5, altimeter 2992. ILS, runway 8 continues. Landing in departing, runway 8. CFR aircraft today direction of flight. All aircraft reach hold short instructions. Advise controller on initial contact you have Foxtrot. Toronto Island Airport information, Foxtrot 1436 Zuma, wind calm. Visibility greater than 20 miles. Sky conditions, clouds at 5,000.
We know where we're going The active runway means the runway where we have to position ourselves at idle, ready for takeoff, before we call the tower. The information letter, pronounced with the phonetic alphabet, lets the controller know we have the latest ATIS, as I mentioned. It changes every hour, so we will change the frequency in a minute so we don't have to listen to this again and again, but we've got to let them know we have the latest. All right, that's the idea behind it. And we don't have to keep hearing the looping, continuous ATIS information recording, so we usually change it to another frequency. So in the simulator, they also show a ticker tape across the top of the screen. It depends which simulator you're running to do that, but not in real planes. We don't have a ticker tape. All right, so the next part in here is the heading indicator set and the bug set. Now, on our heading indicator, we turn the knob until it's the same heading as our compass. Remember that? So we have to set this anytime we're in straight and level, and certainly the first time while we're on the ground. The bug set is optional, but it helps us to remember the heading we're flying at the moment. This can be useful later to have your autopilot fly a specific heading. It'll follow the bug. All right, set ground frequency, or GND, and obtain taxi clearance. Now we change the radio to the ground frequency. This is to talk to the tower and obtain taxi clearance. Well, the tower, there are two frequencies, the ground and the tower, but both radios are physically in the tower, so they can see everything that's happening, the movement in and around the airport. The ground frequency is used to get permission to move your airplane to the active runway or to move airport vehicles around the airport on the ground. The tower frequency you'll contact when you're ready for takeoff or return to the airport. So for now, we'll set the ground frequency, and when we're ready, we will ask for taxi clearance to the active. All right, that's what they mean by that. We're going to leave this part for a whole lesson on itself called radio communications. There is so much to learn here that we're going to assume we have clearance and just get to the active runway, just get there. All right, so typically we would say, this is Cessna 172 Golf Bravo Foxtrot Alpha Mike, taxi to the active, or request taxi to the active. Right? We would ask, that's how we ask for it. And they would say, taxi to the active, and they would tell us how, and I'm going to tell you in a second here. So the taxi section, okay, we have the clearance to give it the gas and roll to the active runway so that we can be ready for takeoff. So while we are taxiing, or while we're moving, we can check a few more things to ensure they work before flying. First thing we check is the brakes check. It's a simple check, really. We release our brakes, give it some gas by pushing a little bit, and start the plane moving, and immediately step on both brakes, either both toe brakes or the period key, and stop the plane. This ensures we have brakes when we need them. We need to stop at the active runway. We might need them on landings. Once we stop, we can now continue on, give it some more throttle and move again and continue on our checklist. Now, this is the tricky part, moving the airplane on the ground. I have people that actually have some trouble with this, so it's going to take some practice, and I need you to be patient with this. A shot of gas to get it started, pull back some to keep going, and you'll notice that even when you pull back the throttle to idle, you keep moving. You might need the brakes to slow you down. Not too fast while taxiing. Your plane could actually tip over, or even worse yet, it could start flying without a runway. It has happened, right? So in our simulator classrooms, we've had people actually taking off from the tarmac right across the grass and just starting to get airborne by the time they hit the water. We've also had some taxis straight into the lake as we have water all around the airport. So that's the fun thing about a simulator. So we can have them do all of that. So now, while we are taxiing at a running pace at the maximum, as if you were running across the tarmac, all right, we're going to do an instruments check while turning. While we're moving, we can check some instruments, see what they're doing before we get up into the air, all right? Better to check them on the ground before we get into the air. So as we turn left and right to get to the active runway, we glance at a few instruments. For instance, the heading indicator should rotate right or left depending on the direction of our turn. Our altimeter should stay steady. We're not going up or down, right? So should our artificial horizon, which we haven't taken yet, but we'll have a quick check of that. So we use a quick check method by saying this out loud. Left, right, steady, decreasing if we're doing a left turn. Or right, left, steady, increasing. All right, they sound a bit similar, don't they? But we'll see that as we go as we go taxiing down the tarmac. So we're referring to the little airplane instrument called the turn and bank indicator. All right, we didn't introduce this instrument earlier. In some classes, they introduced this in the straight and level, which it can be used later in straight and level. But I didn't want to introduce too many instruments all at once. It really turns people off. So the turn and bank indicator now, we can learn a bit more about it, and then later when we start doing turns out in the practice area, we'll learn even more about it. But the turn and bank indicator, or the T and B needle, and the T and B ball, on a left turn, the left airplane wing on the instrument should drop, and the ball should go to the right. So that's why we say the expression left-right. We're seeing the left wing drop in the instrument, and we're seeing the ball slide to the right when we do a turn. The ball is like a steel ball inside a fluid, and it's like a centrifugal force. It wants to go wherever the plane was supposed to be going. All right? So we say left-right. The steady refers to the artificial horizon bar in the middle. Of course it should be steady. We're not banking the plane, or we're not changing our nose attitude up or down. So, but this is a check. I mean, we're making sure that it actually shows steady, right? The final increasing or decreasing refers to the heading indicator dial. Let me demonstrate this. Now it's your turn. Pause this section, save this flight, and start taxiing. I just want you to taxi around the tarmac before we get clearance, and let's talk about how to get to the active. We have this whole pavement area to practice in and no planes around us, which is great. Do left turns, then right turns. Watch your speed. Use your brakes if you need to. Throttle back. Use your brakes. Once you're ready, we'll taxi toward the active runway. Okay, let's taxi toward the active runway. On the way, we're going to stop and do one last check, the run-up. Airports have different rules on where to do this. As you're pushing a lot of air behind you, and you could be blocking other aircraft from getting to the active runway. So, you know, I could talk about back in the 90s. We used to do our run-up just before we took to the active runway. So many airports don't like that now. There's just too many airplanes for that, and we're trying to get around each other while someone's doing a run-up. So many airports do this check before they obtain taxi clearance. Before we even start moving toward the active, we'll do this. And we'll perform this on the tarmac, facing the wind, not far off from where you were parking. So refer to the run-up section in your book. Let's take a look at the run-up section. This is the final check before taking off, the engine check under load. This means that we check the engine while on higher RPM without moving the plane. So we set the parking brake or use the rudder pedal toe brakes, and we spin the propeller faster and check a few things. This is called the run-up, and all planes do it. Airliners even do it. Sometimes they do the run-up after their pushback. Sometimes they do it while they're taxiing. So let's do it here on the tarmac so we aren't blocking other planes on the taxiways. Turn your airplane into the wind, and in this case we turn it to 80 degrees on our heading indicator because that's the active runway. If the active runway is 08, then it's probably facing the wind. All right, so we always take off into wind to help with lift and to help with engine cooling. All right, so once we're positioned into 80 degrees, just not far off from where we were parked, we put on the brakes and we hold them during this procedure. Or we could use the control period keys to hold them on, or both toe brakes on the rudder pedals for more realism. Checklist item, idle to 1,000 RPMs. All right, so ensure your throttle is pulled back and then inch it forward to ensure 1,000 RPM. We will return to this RPM setting once we're done. Fuel quantity and selector on both. Look at the fuel gauges on the left side of your panel. In this easy setting, they are always full. During your walk around, you would have physically looked into each wing tank and even used a fuel dipstick, like this one. The gauges are confirming what you saw during the walk around. The selector switch on the floor is set to both, when you take a look at that. During all my flights, I kept it on both, but many checklists have you check left and then right to see if the engine still runs. We will just glance at them, make sure they're on both. All right, elevator trim, check, set for takeoff. It's a second check. We've done it already, so we know what it's supposed to be, but we're double checking before we take off. There have been planes that couldn't lift off the ground because of this setting, or they had to struggle with the yoke to get off the ground. Whew. This is a safety check. Look at your trim wheel and to ensure that it's in the TO position, or the takeoff position, and use your mouse wheel positioned over the trim dial to change it, or your trim wheel if you happen to have one. Now, we're going to throttle up to 1,700 RPMs. Now we're going to put the engine under load and check a few things. We'll watch our tachometer, gently push the throttle in toward the panel, pull and push until you get it right, whatever it takes. Once stable at around 1,700, we can manage our magneto check. Because this course didn't drag you through 40 hours of ground school, you might not have heard about the engine safety mechanisms built in. One of those is 2 spark plugs on each piston. Our cars have 1 spark plug on each piston. This idea of 2 spark plugs and 2 magnetos, which will spark them, it's a safety initiative. If one fails, the other keeps sparking, and we keep flying. So we need to check both spark plugs, and we do this by using the start switch and change it to left, back to both, right, back to both. We are watching the tachometer while we do this to ensure the RPMs don't drop more than 50 between settings. We will see our simulator is very reliable and stable, but it's still a good check you should try, all right? Let's take a look now at the next checklist item, suction gauge, check green. This is important for some of your instruments that need air vacuum from the engine, such as your heading indicator and your attitude indicator. Engine instruments in the green. Check the small gauges on your left. The temperature, which is called temp, the amp, which is actually a battery check, and the fuel flow are in the green. Just make sure they're all in the green, and they will be in this easy mode simulator. Idle back down to 1,000 RPMs. Now we're ready to go. We're going to set our radios and our avionics at this point, and then we can taxi to the active. With our radio set for the ground frequency, we would normally call to achieve our clearance. As I mentioned, we'll assume clearance and proceed to the active. For the avionics set part, on a cross country, we would set some other radio positioning instruments, or GPS or something like that, while we're still on the ground. This would be the time to do it. Once we get to the active runway, we have to watch for incoming traffic and wait to hear our clearance when they use their call sign. We can't be busy with our head in the instruments trying to do other checklists at this time. All right? So let's do it now before we get there. Now, during our taxi clearance, we would be instructed to hold short runway 08, or hold short of the active. This means we stop before the yellow lines at the threshold of the runway. We actually position our plane facing the incoming traffic until we're ready to call the tower. We're going to be watching for traffic, like right out the window, visual rules. and then we call the tower for clearance to take off. So let's taxi to the active. If you look at the airport diagram on your checklist card, you will notice where runway 8 is, over there on the far left side. We are somewhere on the tarmac before the tower on the right side. That's where you parked. I mean, I'm not sure exactly where you parked, but we're over there somewhere. Taxiways are labeled using letters of the alphabet. When we learn radios, we'll also learn the phonetic alphabet. There's a document for you to download if you haven't downloaded it yet. Ground radio will tell us to taxi alpha and hold short runway 08. This means we use the taxiway alpha or the A taxiway. Remember, they're alphabetical, right? Notice this on your diagram. This is the easy one, as I intended it. But for now, a simple taxiway A all the way to runway 8 and stop before the 2 yellow lines. Lots of left and right turns to check our instruments along the way. Don't go near the water. Let me demonstrate.